How to graph y equals e to the x. This is Tom Reardon, math teacher from Ohio. You will need graph paper and a pencil. Press pause anytime as needed. If you don't have graph paper, you can download this PDF at this website, which can be printed with 20 grids on each side. Y equals e to the x. You'll need graph paper, a grid. Please make a table. We encourage you to make a table. And we're going to use these 5 values. So for 0, e to the 0 power, you should just know this one, okay? But go ahead and complete the table. Use a calculator as needed, and you will need one for most of these values. That's okay, perfectly okay. Press pause. So we said with 0, if you put in 0, e to the 0 power is 1. Any non-zero number raised to the 0 power is 1. E to the first power is just the value for e. We're going to round that to 2.7. E squared, with a calculator, it's about 7.4. And e to the negative 1 power is the reciprocal of e, which is about 0.4. And the reciprocal squared is about 0.14. So those are our 5 key points to get the curve for y equals e to the x. So plotting those, I'll start with 0, 1, just because that's a nice one to go with. That's the y-intercept. Over 1 up 2.7. Over 2 almost 7.5, 7.4. Going to the left, negative 1 almost a half, but a little less. And negative 2 about 0.14. So those 5 points trace out a curve. We'll connect the points. And now we need to look at the end behavior. For example, what's happening at this end, what's happening at this end. So we'll start with as x gets very large, and that's in this direction, what happens to y. So in analyzing that, if x were to be 1,000, e to the 1,000th power, 2.7 times 2.7, 1,000 times, would be a very, very large positive number. We show that on the graph this way. So as x gets large in the positive direction, y gets larger quickly. So that's how we'll indicate that end behavior. As x gets very small, but in the negative direction, this direction, what happens to y? So example, if x is a negative 1,000, y would be e to the negative 1,000th. By definition would be 1 over e to the positive 1,000th. So it'd be 1 over this very, very large positive number, which is very, very close to 0, but still positive. And we would indicate that graph out here, flattening out here. Never gets to 0. And so we're going to say that the y-axis then is a horizontal boundary line. So the line y equals 0 is called an asymptote. Curve gets really close to it, but never actually touches it. Some terminology, we've got a y-intercept on it. And like we just mentioned, we also have a horizontal asymptote, the x-axis, the line y equals 0. For the e to the x dance, we're going to have 5 points, starting with the y-intercept. When x is 0, y is 1, e to the 0 is 1. So from the origin, we'll write 1 and up 2.7. E is about 2.7, a little bit bigger than that. Right 2 up 7.4, 2.7 squared is about 7.4. Left 1, this is the reciprocal of e, about 4/10. And left 2 up about 0.14, which is pretty close to 0 already. So those are the 5 key points for the e to the x dance. When we connect the points, we get that kind of easy chair look. And then we go ahead and put in the end behavior that we know. This again is an example of a curve that exhibits exponential growth. As x increases, y increases very, very rapidly. Okay, this is exponential growth. Domain and range for this function. Again, we'll look at a graph and a table. And for the domain, if you look along the x-axis, every point, every value on the x-axis has a y value above it somewhere. So all real numbers is the domain. The range will start with 0. It's not included, but everything above it is. Okay, these y values have either next to the right or to the left. So we say these are the positive real numbers for the range, and we write it, the set of all y, such that y is a member of the reals, and y is strictly greater than 0. Note that 0 is not included again because the x-axis is an asymptote, so it's strictly greater than 0. Where would you see this curve in the world? So here's an example of bacteria growth. That's exponential growth, kind of flat, and then takes off like crazy. We encourage you to interact with another video in this series. We especially would like you to do y equals the natural log of x, because it's very much related to e to the x.